The colonization of Earth's moon is a complex and speculative subject that draws from both current scientific research and science fiction. While no permanent human colonies exist on the moon today, various nations, private companies, and international partnerships have set long-term goals for moon exploration and colonization. Here's a breakdown of the specifics and details surrounding this topic. Historical context. The space race, 1960s-1970s. The first successful human mission to the moon was NASA's Apollo 11 mission, which landed Neil Armstrong and Buzz Aldrin on the lunar surface on July 20, 1969. This marked the beginning of human exploration of the moon, though no permanent colonies were established. Post-Apollo program. After Apollo, moon exploration was largely abandoned due to budget cuts and shifting priorities. However, interest in returning to the moon has grown significantly in the 21st century, driven by scientific, strategic, and commercial interests. Modern plans for colonization. NASA's Artemis program. Goal. NASA's Artemis program is designed to return humans to the moon, aiming for a sustainable presence by 2028. It is focused on building infrastructure that could lead to a permanent colony. Lunar Gateway. A key component of the Artemis mission is the Lunar Gateway, a space station in lunar orbit that will serve as a staging point for missions to the lunar surface and other destinations in deep space. Lunar surface operations. NASA plans to send astronauts to the moon's south pole, which is believed to have water ice, a crucial resource for sustaining human life. The Lunar Reconnaissance Orbiter and other missions have already mapped out areas of interest. Infrastructure. By the end of the 2020s or early 2030s, NASA envisions having lunar habitats, power systems, rovers, and in situ resource utilization (ISRU) technologies in place. International involvement. China. China has made significant advancements in lunar exploration with its Chang'e program. Chang'e 4, for example, was the first mission to land on the far side of the moon in 2019. China plans to build a lunar research station by the 2030s. Russia. Russia, through its space agency Roscosmos, has expressed interest in building a base on the moon, particularly to mine resources and test new technologies. India. The Indian Space Research Organisation, ISRO, has also developed lunar exploration missions, including Chandrayaan-1 and Chandrayaan-2, and has plans for Chandrayaan-3. While ISRO's lunar program is currently more focused on robotic exploration, it may lead to manned missions in the future. Private sector contribution. SpaceX. SpaceX, led by Elon Musk, is one of the most ambitious private companies aiming for moon colonization. Musk's Starship spacecraft is being designed for missions to the moon, Mars, and beyond. SpaceX is a key contractor for NASA's Artemis program and has been contracted to land astronauts on the moon. Blue Origin. Founded by Jeff Bezos, Blue Origin is also involved in lunar exploration. The company is developing the Blue Moon lander, which is designed to deliver cargo to the lunar surface. Blue Origin aims to facilitate the human settlement of the moon, with plans to establish a permanent human presence by the 2040s. Key challenges for lunar colonization. Lunar resources. Water ice. Water is essential for life support, and lunar water ice, particularly at the moon's poles, is a critical resource for sustaining future colonies. Ice can also be converted into hydrogen and oxygen, which are key components of rocket fuel. Helium-3. The Moon is rich in helium-3, an isotope that could be used in future nuclear fusion energy reactors. This makes it a potential resource for energy production. Regolith. The lunar surface is covered with a layer of regolith, which could potentially be used for construction materials or other purposes. Radiation protection. Cosmic and solar radiation. Without Earth's atmosphere or magnetic field, the Moon is exposed to harmful cosmic and solar radiation. This poses a major threat to human health and must be mitigated using advanced shielding technology or by building habitats below the lunar surface. Lunar lava tubes. Some scientists suggest using the lunar lava tubes, natural underground cavities formed by ancient volcanic activity, as shelters. These could provide protection from radiation, micrometeorite impacts, and temperature extremes. Lunar gravity. The Moon's gravity is only about 1/6 of Earth's, which can have unknown long-term effects on human health, particularly on bone density and muscle mass. Scientists will need to study these effects and potentially develop countermeasures, like exercise regimens or gravity-generating technology. Sustaining life support systems. Colonizing the Moon will require reliable life support systems for oxygen, water, food, and waste management. Technologies such as closed-loop life support systems, which recycle resources, are being developed. Food production. Growing food on the Moon will be necessary for long-term sustainability. Efforts are underway to research hydroponic and aeroponic farming techniques that could work in the Moon's environment. Energy generation and solar power. The Moon's surface is exposed to constant sunlight for half of its orbit, providing ample opportunity for solar power generation. Solar panels could be used to power lunar habitats and equipment. Nuclear power. Given the Moon's long nights, about 14 Earth days, nuclear reactors are also considered as a potential energy source. The timeline for colonization. In 2020s, NASA's Artemis program aims to return astronauts to the Moon by 2025. With long-term goals for sustainable human exploration by the end of the decade. SpaceX and Blue Origin are working on the technology for landing on and exploring the lunar surface. 2030s. The establishment of a lunar base or outpost could begin in the 2030s, with plans for scientific research, resource extraction, and possibly the first steps toward a self-sustaining colony. 2040s and beyond. Some experts speculate that by the 2040s or 2050s, permanent lunar colonies could be in place. These colonies would likely focus on scientific research, resource mining, and possibly tourism. Ethical and political considerations. Space law. The Outer Space Treaty, 1967, prohibits any nation from claiming sovereignty over the Moon. Colonization efforts will need to operate within these legal frameworks, though future treaties may address issues like resource extraction and settlement. Environmental impact. There are concerns about the environmental impact of human activity on the Moon, including the potential for contamination or disruption of the Moon's natural state. Conclusion. While we are not yet at the point of full-scale colonization of the moon, several nations and private companies are actively working on the technologies and infrastructure that will make lunar settlements a reality in the coming decades. The colonization of the moon will likely follow a series of incremental steps, including scientific exploration, resource extraction, and eventually, permanent habitats that can support human life. The next few decades will likely see significant progress in this ambitious goal,